Number 19, this is the one about response times. It does say be sure to define the parameter of interest. It's written here. I would be defining let what equal what. What? And it's going to be something like that. Mean response time to all accidents involving life-threatening injuries. But it's probably better to go ahead and include last year. And how specific does this one talk about for who? This one doesn't say city manager.
Yeah, it's in the city.
For this city or something. I would definitely include that because that's what you're wanting to see if this city's doing better. But technically that could be included in population. So it would, in this problem, I wouldn't count off for it because I didn't ask for population too. Alright, so this one actually sets you up to do two different problems. If I skip 20, it gives you this, and it also gives you this. Number 20 was running it as a proportions one, and I just didn't feel like dealing with that one right now. So what is our claim?
It takes an average of 6.7 minutes to treat people with like that.
Alright, so what are they testing?
Mean response time.
Whether it has what? What was it?
6.7.
So even though the problem is setting up for this, is that really what we're using? And that problem's kind of confusing because of that. It's like it gives you more information than you need. So you're doing what here? Did you want to see if we are now less than last year? Right. So a type 1 error, and I am going to type a little bit, but I'm probably not going to type word for word everything, but enough to where you can see this if you need to. In general, a type 1 error in this scenario would be what?
They conclude that response time is not improved what it actually has.
Data shows what? Data shows we show, they show what?
The response time is not improved or decreased or whatever.
Response time has decreased by adding a chain.
So you did them opposite. So if I wanted to, you're saying we reject would mean we say right? Whereas this one would be less than 6.7. Here would be that it actually is less than 6.7. We say what? So sometimes it helps to
Let me see what if it's equal to 6.79.
the whole interpretation of errors is basically only referencing the alternative. And it's easier to think about it that way. So like my alternative is less than 6.7. So referencing less than 6.7 in all of them is the easiest way to do it. If not, you're going to confuse yourself. So data showed that the response time has decreased, but you said what? So what would our consequences be there? What?
Like they stop trying to improve and
That's a terrible written description, but you understand what I mean there. What's going on? So they should be allocating money, time, effort into decreasing it, but they don't think they need to, so they're not.
So the true or false part has to do with if it's equal to 6.7.
So you know how here we write HO is false, but we also write right off to the side that. And that's what we actually use thinking through it is this part.
Yeah.
So yes, we either say the alternative hypothesis true here or not the alternative hypothesis here. All right, so on the other end, a type 2 error would be what? So what would be the consequences there?
it's like unnecessarily hard to do to increase their response.
The wording of all this is going to be different, and I'm trying to do enough to where I can fit a response on the board without getting into too much detail. So y'all, I would imagine y'all have much better written responses than I'm putting up there. But so the consequence is we didn't actually need to be doing anything else, but they're allocating time, effort, money, whatever to make it better, but it already has gotten better, so it was unnecessary. So in this one, which one would be more serious? That we stop trying to improve response times when we should be working on them, or we have extra time, money, effort to reduce them even more than they should be? The first one's a lot worse. I mean, yes, time, effort, money is bad here, but is there really a downfall to having better response times than we were even wanting? So this one, we should be improving these response times, but we're not, and we're not also doing anything about it. So type 1 would definitely be worse in this scenario.
Can you draw up a little chart? Because type 2 would mean it failed to reject, right?
Mm-hmm. So it actually was less than 6.7, but that's not what we showed.
So what's this?
So then the data showed that it is not decreased. Data showed not less than 6.7, but it actually was less than 6.7.
Fail to reject. Wouldn't it mean that that's true?
This happened, but we didn't come up with the right conclusion for this.
Is it fail to reject saying that it is?
Fail to reject means we couldn't overturn the null hypothesis. If you reject, that's when you have evidence of the alternative.
Oh, okay.
All right, so another scenario that makes a lot of sense as far as like decision making. The first one is more of a good real world interpretation of this type of problem in the sense of like necessity. But this one is another good, really like plan ahead kind of thing. You're thinking about opening a restaurant and searching for a good location. From research you have done, you know that the mean income of those living near restaurants near the restaurant must be over $85,000 to support the type of upscale restaurant you wish to open. Basically, that's saying if there's some restaurant that's like $200 a plate, putting it in the middle of a place that the average income is like $20,000 would be pointless because they're going to go out of business because nobody's going to eat there. So they want to make sure that the area is sustainable for that type of restaurant. So our null hypothesis here would be what? And our alternative would be use greater than, because we want to make sure there is sufficient evidence that we should open our restaurant, or sufficient evidence that the area can sustain this type of business. Defining our parameter would be the mean income of those living near the restaurant. A type 1 here so we reject the null hypothesis. So we, or data showed what if we rejected it? Data showed what if we rejected it?
Or it actually wasn't.
And another way you could say that same thing is data said the area could support it, but actually can't. So our consequence would be what? For this person going to open the,
They wouldn't get a lot of business.
so the person going, deciding whether or not they're going to open the restaurant comes to us, we do the numbers, we throw it back to them, so the company ends up doing what? So the restaurant opens up, but they shouldn't have, or but the neighborhood can't sustain it. So what? Type 2 error would be that the data shows what? So data shows that the mean is not over 85,000. It actually is. Again, saying data said the area could not support it. It actually could. And again, realize I'm doing shorthand notation here. You should actually be making decent sentences. So here in this scenario, the restaurant what? I just wanted to word it this way because there are a lot of scenarios where it's an easy way to say, so they missed out on an opportunity. So it's kind of like the game show 30-second breathing example could have been explained as you missed out on an opportunity to win the money. If you had to choose one of these standard significance levels, would you choose alpha of 0.01, 0.05, or 0.10? And why? So a type 1 error was much worse. Probability of a type 1 error.
You would choose alpha to do what? To decrease?
So type 1 error was much worse. Alpha is probability of type 1 error. So we want a small alpha. So I would probably say the smallest one is the best choice. questions with 21? Probably should have said this at the beginning, but y'all are going to do a quiz assignment after this, so hope you're paying attention. Your company markets a computerized device for detecting high blood pressure. The device measures an individual's blood pressure once per hour at randomly selected times throughout a 12-hour period. Then it calculates the mean systolic pressure for the sample of the measurements. Based on the sample results, the device determines whether there is significant evidence that the individual's actual mean systolic pressure is greater than 130. If so, it recommends that the person seek medical attention. So our null hypothesis here is mu equals what? And it didn't give me measurements. I'm assuming that they're talking about beats per minute. I honestly can't be sure with the way it was worded. I'm just doing units so that I have some units. My alternative is what? And then we could define mu as the mean blood pressure of this individual over a 12-hour period. A type 1 error would be what? What's consequence? So what is a type 2 error?
You find that it's not greater than 130 units, but it actually is.
So our consequence would be
You don't get
so if you were to answer a question like this on like a test or a quiz or something, I would get into maybe at least 2 sentences about something like this. Like, don't just be so straightforward. Justify what the consequences actually would be, like what bad would happen from it. Like I said, I wrote really straightforward up here on the board so that you have something to look at, but your answers are going to vary. Questions on homework?